Okay, so in this question, this was taken from the standard paper, May 22 for the Math E-Assessment for the IB curriculum for your MYP certificate. This is from the standard paper, but the skills are needed for both standard and extended, so let's get into it. Okay, so we have here, this will be an interactive tool on the assessments, but we have different stages of that interactive tool. So stage 1 was just a triangle. Stage 2, you can see they've added some triangles to that. Stage 3, they've continued that pattern, and then we have stage 4. So the first question has asked, can we describe how stage 2 includes 5 triangles? So if we go to stage 2, you can obviously see that it's 1, 2, 3, 4 triangles, and then you have a large triangle that they make together. So that's how they're looking at these shapes. So then that brings us to question B, where we have a table. N stands for the stage, and then we have T is how many triangles that we see. So the first stage has 1 triangle. We've just established the second one has 2. The third one has 1, 2, 3, 4, 5, 6, 7. Then you've got 8, and then you've got 9. Okay, so that's how we are looking at these shapes. So if you look here, you should notice that each time they continue this pattern on, it's increasing by 4. You get 4 triangles extra. So your missing digits should be 17 and then should be 21. Question C, it will always then ask you maybe to describe the pattern in words. So it'll look for 2 things. So we've already discussed one. The first thing that you notice is that each time it is increasing by 4. Yeah, you should also notice in this case that they're all odd numbers. Okay, so you can see that they're all odd numbers. You can also see that it's an arithmetic sequence with a difference of 4. We know it's a linear sequence with a difference of 4, or a constant distance. So there's a range of things you can say, but you just have to highlight 2 things you notice. Then it says find the general rule of T in terms of N. So just make sure you're using the letters that they give you, so the correct terminology. So on the formula page, you will be given the formula for this anyway. So there's different ways you can do it, but you'll be given it. So the formula on the formula page will be seen as UN equals U1 plus N minus 1 D. So in this case, we know that D is 4. We know the first term is 1, so that's over here. So then you just need to substitute that in. Remember, they don't use U, they use T. So you can write T equals 1 plus N minus 1, and the difference is 4. So if you expand that and tidy that up a little bit, you should get 4N. This will give you negative 4, but you have that plus 1. So it should be 4N and plus 3. Or minus 3, because it's a negative. So that is the nth term, basically, of the number of triangles. So 4n minus 1. How are we going to verify that answer? Well, we're going to substitute in, when it asks you to verify, you need to substitute in one of the values that you predicted, okay? So anything that is 5 or greater. So if I substitute in 5, I know my answer should be 17, based on what I've predicted. So let's see if that is right. So 4 times by 5 is 20, minus 3 is 17, which makes the prediction right. Then the next part of this question then, if we move on, it is going on to the investigation part. So here we're looking at the triangles in a bit more detail. So it's still the same pattern, but this time we are talking about the perimeter of the shape. So the L stands for the length of the outer triangle. Okay, so the first one, the length is 1, which means the perimeter is 3, because 1, 2, 3. The stage 2, obviously it's made up of 2 lengths. So you've got 2, 4, 6 on the outside, and so on. So we're talking about the perimeter of these shapes. Okay, so the first says, show the perimeter of the outer triangle in stage 4 is 24. So stage 4 is over here. Well, if one side is just 8, we know that 8 times by 3, because a triangle has 3 sides, in this case should be 24. Okay, so that's a nice, easy question. Right, then we're going to now move on to the part that is with roughly usually between 20 and 23 marks, which is a lot, but a lot of these marks are easy if you practice and practice these questions. So it says we're going to investigate the values in the table. This is the question. And look at the relationship at the perimeter in terms of n. It wants us to predict more values. It wants us to describe the pattern from the table for the lengths and for the perimeter in words. It wants us to write down a general rule for the perimeter and then test, verify and justify. Okay, so I'm not going to do it like I would expect, but I just want to give you some tips that you should be doing. The table will always give you some extra space. Mine's gave you a little bit more, but it will always give you an extra space, and we're going to fill it in. So this should be a nice easy few marks. So if you look, the side length of the outer triangle, it goes 1, 2, 4, 8. So you should notice that it is doubling each time. So the one after that should be 16. Double that is 32, and so on. So in terms of the general rule, if I had to write one for this, because it is doubling each time, we know that it's a geometric sequence. Again, you're given the geometric sequence formula on the formula page, which is UN equals U1 times by R n minus 1. R is the common ratio, which is multiplying each time. So in this case, it is multiplying by 2, and the first term is 1. So if I want to write the general rule for the first one, it is just 1 multiply 2 n minus 1. And that is for L. So the general rule for L is just 2 and then n minus 1. Okay, you can test, does that work? If you put the first one in, you should have 1 minus 1, which is 0, and then 2 to the power of 0 is just 1. Yeah, if you substitute 2 in, you get 2, and so on. Then the second one, you should notice, if you're describing it in words, that we notice that each time we are multiplying each time also by 2, by 2, by 2. This one's a little bit different because the first term is not 1. So for the second one, if I want to work out what P is, the first term is 3. I'm going to times that by the ratio, which is 2, and then n minus 1. So that is for the perimeter of the shape. It's 3 times 2n minus 1. And they are the two general rules. I know it didn't ask for the first one, but they are. So the first one, so the outer triangle, we notice that it times us by 2 each time. And for the perimeter, we notice it also times by 2 each time. Then it says test, verify, and justify. So if you're testing the rule, you want to be putting one of the numbers in that they gave you. So if I'm testing my rule, I am going to test. I'm going to put 3 times by 2. And let's pick the second one. So 2 minus 1. And this is for P. So if that's correct, the answer should be 6. So 3 times by 2 minus 1 is just 1, which will leave 2 to the power of 1, which is 6. So that is test. Verify in this question, I'm going to be putting, so that's test. Verifying, I need to be putting in one of the numbers that I predicted. So I'm just going to put in 6. So 3 times 2 is 6 minus 1. We know that 6 minus 1 is 2 to the power of 5. So, oh, I forgot to actually predict these values, so just be careful. So if I'm timesing by 2 each time, it should be 48 and then 96. So 2 times 2 times 2 times 2 should be 3 times 32. And then 3 times 32 is 96. So that is verifying my answer. Then it comes to the justify part. So we need to try and find a connection of how we can justify the answer with the formulas that we've already got. Well, there's one way that we can do this is that we should notice that the length of a side, so this formula here, the length of it, you should notice that actually it's just multiplying each time by 3. So 1 times by 3 is 3, 2 times 3 is 6, 4 times 3 is 12, 8 times 3 is 24. So when we're justifying, we can say that we know the formula for the outer triangle, the length of one of the outer triangles. We need to times that by 3, and that will get us the perimeter. Does that work? Well, if we times it by 3, what do we get? We will get 3 times 2n minus 1, which is the same formula as we got over here. So when it comes to the justify part, it can be quite tricky sometimes, but you just have to try and think of how can we get that formula a different way.